This is Darren Marchant, and this is American Nomad News. Astroponics. This is Darren Marchant with American Nomad News. And thoughts on rockets. Now, I tend to spend a lot of my time talking about life support systems and astroponics. But you don't get astroponics in space without propulsion. And so a discussion of propulsion systems and their potentials is in order. Now, from the surface of Earth to space requires so much power, and I'll leave out all the technical jargon because I think that confuses things and kind of blocks people's minds. So I want to just talk about things in basic simplicities. So that's why you see these very large rockets that their fuel tanks are much larger than their payload, and they have really large, loud engines that produce a lot of smoke and flame, and all of this basically spells into really powerful but inefficient. And it's just, it comes with the territory if you want to go from the surface of the Earth to low Earth orbit. But once you get to low Earth orbit, things change a bit. It comes down to, once you're in low Earth orbit, if you are in a hurry, you've got living beings on board and not a lot of shielding and that kind of thing, and you want to go from low Earth orbit to the moon, say, or to the orbit of the moon, and you don't want to take a lot of time, then you use those same kinds of rockets, inefficient but powerful and fast. Go now, right? Like that guy with the big jacked up truck that always has to rev his engine at the street light. That guy. Okay. But there's a whole nother class of engines that are very popular to build on to satellites and other probes and things that they really need efficiency more than speed and power. And they're called electric propulsion. And there's a few varieties, but basically it comes down to you're emitting a gas into a space in the machine that causes the gas to pick up an electric charge. And that electric charge, the way this electric propulsion system works out, it's designed so that atom or molecule of gas, depending on what gas you're using, whether it's elemental or a compound or not element, what am I thinking? It's either elemental or it's molecule, okay. That charged gas wants to leave, it wants to go away really fast. And that, for that one little atom, say of argon, that will impart a lot of energy per mass, right, onto the rocket. But because an atom all by itself is very tiny, the actual power, effect on the propelled object isn't very much, but it's very efficient. And so over time, these satellites, they can quiet little plasma coming off of this thing, and it usually glows just a little bit. It's not really super bright, and there's no smoke, and there's very, very little noise at all when they do it in labs here on Earth. And in space, the vibration doesn't go anywhere because it's a hard vacuum around it. So you're not going to hear anything anyway. But it's very efficient that way. Now there's another class of rockets that's very similar to the liquid fuel rockets that you see and I'm kind of trying to shield my cell phone because it's a falling mist. And it's getting my cell phone wet, and I want to be careful because it's got a cracked screen. I don't know. I've dropped it like twice. I really need to get it fixed. And that's solid rocket motors. Now, solid rocket motors are kind of just a little bit unpopular with the rocket crowd because you can't throttle them. That's one difference between solid rocket motors, electric propulsion, and liquid fuel. Electric propulsion and liquid fuel, you can pull back on the gas on them things and they stop. You can stop propelling. You can stop adding propulsion. And with solid rocket motors, no. And there's another problem with solid rocket motors that's an issue. And that's that they're dirty. Now here on Earth, particulate really isn't that big of a deal because it's going to settle out with rain, right? We're more concerned about greenhouse gases and things that are toxic to animals and stuff. But if it's something that's just kind of dust and it's going to settle out, it's not a big deal. But in low Earth orbit or out in space, particles that are grainy, larger than atoms, and they're moving very fast, that's like sandblasting on steroids. It's pretty rough stuff for ships. So it counts as orbital debris. And it's impossible to see it. You cannot, even if you were 3 inches away from it with sensitive instruments, you might not be able to really tell particulate in orbit. It's like super hard to see. But you would definitely see the damage to your surfaces of your craft as the metal is eaten away. In fact, one of the things that NASA did was some experiments with different materials because they were getting atomic oxygen atoms, individual atoms, were making little pits on the surface of their material, and it was happening so much, it was like it's sandblasting on an atomic scale. It was ridiculous. And so they have to have special materials that can withstand a lot of this. It's one of the things that in the future, as we get more and more activity in space, we want to address some of these things. And there's ways to do that. There really is. So one way that solid rocket motors actually could be controlled is through incrementation, cartridges. Okay, now let's say that you're on the moon and you have a craft that, and solid rocket motors are fairly cheap and safe to handle. They're not like liquid fuel that can blow up and stuff. They got a lot of safety value to them if you work them right. So a shotgun has cartridges. You put 6 or 7 of these into the shotgun, and you cock the shotgun, pull back the hammer, boom, right? You got boom. And that's propulsion. That's the kick of a gun, is when it pushes back on you. Now, one of the things about solid rocket motors is they're typically made, not always, but typically made so that you have to pump oxygen down through them. They're like a cylinder. They're a thick-walled cylinder, and the cylinder itself is actually the fuel. And the oxidizer goes down through the middle, and that creates that really strong push. Not all of them are like that. Like the little toy rocket ones are, you don't have to have that. You just light them, and the oxygen's built into the chemistry of the solid material. But now let's imagine that you have a system whereby you have several of these cartridges, and they're precision made so that you know how much thrust you're going to get out of each cartridge. And it's almost enough to safely land on the surface of the moon or take off, right? It's got that balance to it. And so you actually have two rocket systems. You have a liquid fuel system and you have a cartridge system. And the cartridge system, what it does is it gives you that extra boost to land or to control vectors, like you could use them to emergency maneuvers in order to avoid orbital debris or that kind of thing. So you load a you engage the mechanism to load a cartridge into the chamber. Oxygen is fed down through the center and the thing is lit. And out comes your thrust. And it's gonna burn up. Just like a shotgun shell is ejected from the shotgun, you eject the cartridge into a capture container because you don't want that stuff floating around. It's called foreign object defect, FOD. It's a typical Air Force and airport security issue. They want you to pick up all your tools and they don't want stuff laying around the flight deck because it can get sicked up in the engine. So here we go. You're in orbit and your systems are telling you, your flight control guys are telling you, hey, look, there's an uncontrolled object coming your way. We need you to move out of the way, right? Your system says, beep, 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 you need to move. Okay, so you engage your cartridge and aim it in the right direction, and you get 60-80% of your propulsion that you need to move out of the way in that thrust. It spins the cartridge, expels it, and your electric propulsion finishes off, right? You might even be running both at the same time. You got electric propulsion that starts up immediately as your alarms start going off, and you engage the cartridge because you want to move. You see this thing coming. You've got it on, it's tracking, and you can see it on your instrumentation. You're like, oh crap, I got an old dead Russian satellite that nobody ever picked up, cleaned up. I gotta move out of the way, oh boy. And you hit that thruster, plink, 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 it goes into the container. It's controlled, it's shut off. And it's not entirely what you need. That's that padding that you have. So the electric propulsion shuts off when it reaches exactly the amount of thrust differential that you need. That change of velocity, the delta V. So cartridge solid rocket motors. Another concept, another way to look at it. Maybe some of the things that I've mentioned are not, you know, when the engineers get to look at them and say, no, that doesn't really work because of, okay, I totally get that. But there might be an application for cartridge solid rocket motors. You got 50 in a clip, just like shotgun, right? Just like a banana clip on a M16. Click, and they could be that big around and 2 feet long. They could be the size of a shotgun cartridge to fit the parameters of the situation. There you go.